Okay, the unit of current density is, or you know that the current density means the amount of current which passing through a unit amount of area. So for example, the cross-sectional area of this conductor is a 10 meter squared, 10 meter squared, and the current passing through the conductor is totally 70 ampere. So at this conductor, the current intensity would be the amount of current which is passing through a unit area. So therefore, the 70 ampere, you have to divide the total cross-sectional area 10. You will end up with the answer is 7 ampere meter minus 2. So the current density is the unit which is representing you the amount of current which is passing through a unit cross-sectional area. So therefore, the answer, normally we denote this equation is J. So J is equal to I over A. Well, you know that the ampere, i.e. the unit of I is ampere, and the cross-sectional area would become meter minus 2. So the answer is first answer. The main scale of a vernier caliper is marked in 1 millimeter divisions. The length of 49 divisions of main scale is equal to 50 vernier divisions. The measurements which is not taken by this instrument would be, okay. So the data that is there given, which is the length of 49 divisions of main scale is equal to 50 vernier divisions. So you can conclude that the least count would be, so the least count would be, this is a shortcut, you could conclude that 1 millimeter, because there is a separation by 1 millimeter, by total vernier division is 50. So the length of 49 divisions is, the scale is equal to 50 vernier divisions. So the further 1 millimeter is divided into extra 50 units. So that is why I'm counting the least count by this way. So 1 over 50. So you will get the least count would be, for this, you can conclude the least count would be 0.02 millimeter. Okay. And you know that in any instrument, when you are getting the reading by using any instrument, always the reading would be the integer times of the least count. So that is the only possible way. So that is the only the possible reading that you obtain from any measuring instrument. So therefore, by observing this whole answer, you will not get any answers which is in decimal times of the least count. So by means this, you can conclude the second answer is wrong one, because you will not get 0.03 millimeter when the least count is 0.02 millimeter. So the answer second is wrong. The length of the string of a simple pendulum is L, and the radius and the mass of the pendulum is R and M respectively. The periodic time of the pendulum is T. Now the pendulum bob is replaced by another bob of same material. Okay, you have to note this point that they are using the same material of mass atom. The periodic time of new pendulums. Okay, all you know the equation of the periodic time of simple harmonic, which is a simple harmonic motion, simple pendulum. The T is equal to 2 pi into square root L over G. Here you have to be careful that the L is not the length of the rope. It is the L represents, and there is the meaning of the L is the distance between the point where it is attached and the display, and to the display, the distance of the center of mass of the object. So you have to conclude the total distance from center of mass of the bob. So initially the length is not L. So initially you have to consider this L is L plus R, L plus R. But normally you can say that suddenly you can conclude that the L, so in mass, the total periodic time of a pendulum, it doesn't depend on the mass. It is only depend on the L, and suddenly you can conclude the answer is first. No, that's right. But for this question, which is not possible, because they are, what they are doing is they are increasing this pair mass by 8 times in same material. When you are using the same material, the always the density is being constant. Is m over v. So when you didn't change the material, the density will remain unchanged. So therefore, when you increase the mass in 8 times, definitely the volume should increase 8 times. Or you know the equation of the volume of an sphere is 4 by 3 pi r cube, which is equal to V. So when you increase the V by 8 times, definitely the radius should be increased in 2 times. So after changing the mass, now the distance would change like L plus 2R, because initially the length is L and now you change the by 8m. So by you change the 8m, so now this distance will become 2R. So total distance will become L plus 2R. Okay, so now final length, the final distance from the point where it is attached to the center of mass of the bulb will become L plus 2R. So definitely you know the T is directly proportional to square root of L. So therefore that you will end up the answer with T into square root L plus 2R over L plus R by using simple maths, and the answer will end up with third answer. Consider the following statement regarding the traveling microscope. Both eyepiece and objective piece are convex lenses. The distance between the eyepiece and the objective piece should be adjusted to focus an object. The final image is virtual and magnified. The correct statement is R. Okay. All you know, they're asking the correct statements, and all you know that which we are using is traveling microscope. What does it mean? It means that there is in a microscope which could move vertically upwards or downwards. So there's a railing to move upwards or downwards, but there is a simple microscope. I mean a microscope. There's a simple microscope where you studied that about the principle of microscope in unit 3 in light section. So all you know that there is a microscope, but which can move at this point. So that is what we are using traveling microscope. So for this question, both eyepiece and the objective piece are convex lenses. Yes, that's true, because we are using just a microscope. Okay. The distance between the eyepiece and the objective piece should be adjusted to focus an object. No, that's true. That's false. That's false, because when we are using the traveling microscope, first of all, we need to get the clear image in crosswire. So the way that you have to use the traveling microscope, first of all, you need to adjust the eyepiece forward or backwards and get clear image of crosswire. And afterwards, you have to focus the object. How do you focus the object? Is by adjusting the microscope totally by hand. We do not adjust the distance between the objective lens and eyepiece. Sometimes you may think that there's a knob to adjust. There's a knob to adjust something. What is the purpose of this knob? Okay, next time when you enter into the physics lab, you please consider well that when you start to rotate this knob, it will not change the distance between these two lenses. But what does it do? It is allow to you move total microscope further forwards or backwards. Totally, this makes displacement for the total displacement to the total microscope. It is not changing the displacement within this. Then how do we focus the object to get clear image in crosswire? So better way is, for example, I'm telling here, this is a capillary tube, and you want to measure the internal diameter of this capillary tube, and you are placing your traveling microscope here. So this is the adjusting knob. So when you are observing in crosswire, you could see this image of this cross-sectional area of capillary tube. But when you are observing this, sometimes you may get blurred image of this capillary tube. So how do we adjust to get clear sharp image in crosswire? The only way is adjusting the distance between these two. Sometimes there's a need, it will create it, that you need to adjust a very tiny displacement further away or towards to the this cross-sectional area for tiny movements. When you are using your hand, you will not control the movement. But when this knob is, that time this knob is highly useful. When you rotate this, it can adjust this distance, tiny displacement, in tiny amount of displacement. So that will allow us to get clear, sharp image. So that is why we are having this knob, and this knob is not for the changing the displacement, sorry, changing the distance between these two lenses. So that's right. So they are telling that the distance between the eyepiece and the objective piece should be adjusted to focus an object. No, that's wrong. So therefore A is right and B is wrong. So this therefore no, no, and no. The A is right. So the answer will be 1/4. So just see the fourth. The final image is virtual and magnified. Yes, that's true. We already mentioned that we are using a simple microscope. A simple microscope means they are the only one lens. This is a compound microscope. This compound microscope that what we are using in traveling microscope. So in this compound microscope, the final image is virtual and magnified. Yes, that's true. So the answer will be the displacement x of a particle which follows a simple harmonic motion gives an x is equal to a sine omega t plus pi by 2. The displacement at t0 is given by. So that is so simple. They are giving the equation and asking the answer. So you just put 0 for this t, and finally the omega into t will become 0. So the answer, and for the x is equal to, it will become a into sine pi by 2. So all you know that the pi is equal to 180 degrees. So when you divide by 2, when you divide 180 by 2, it will end up with 90 degrees. Sine 90 is 1. So x is equal to a into 1. So the displacement is equal to the amplitude is fifth answer. That's so simple. Same masses of two liquids, P and Q, are in two identical calorimeter of negligible heat capacity. So you don't need to consider about the calorimeter. When these two calorimeters are kept in refrigerator, the liquid P is cooling faster than liquid Q. Consider the following statement. Okay, that is an important data. They are given. Liquid P is cooling faster than liquid Q in same masses. When the masses is same and the liquid P is cooling faster when compared to the liquid Q, so you can conclude that specific heat capacity of P is lower than Q. So that is the data they are giving in hidden form. Okay. Liquid P is most suitable than Q to make liquid glass thermometer. Well, you know that when we are creating a thermometer, always we expect that the thermometer should be low heat capacity. So for creating a low heat capacity thermometer, we need a liquid which has low specific heat capacity. So therefore, the P has low specific heat capacity. And they are also mentioning that liquid P is more suitable than Q to make a liquid glass thermometer. So that's true because it has low specific heat capacity when comparing with Q. So the A is right. And when you see the statement B, okay, liquid P is more suitable than Q for using as a refrigerated liquid. Well, you know that when we are using a refrigerated liquid, the property of refrigerated liquid should be absorbing a lot of heat. So when it needs a lot of absorbs a lot of heat, the specific heat capacity of the liquid should be high. So therefore, the specific heat capacity of the liquid is Q is high when comparing with P, but they are telling liquid P is more suitable than Q for using as a refrigerated liquid. No, that statement is false because, for example, in our daily life also we are using for car radiator coolant liquid is water because the water can absorb a lot of heat to increase this temperature by 1 degree Celsius because its specific heat capacity is higher. So that is why we are using water as a coolant liquid for our car radiators also. So there he is telling that liquid P is more suitable than Q for using as a refrigerated liquid. No, for refrigerated liquid, we need a liquid which has higher specific heat capacity. So therefore, his Q is good one. So they are telling that P is more suitable. No, that statement is wrong. So in C, liquid P is most suitable than Q to make a liquid reservoir of constant temperature in the laboratory. Normally, if we need to create a constant temperature reservoir, so we need some liquid that should be, the heat capacity of the liquid should be high. So for example, for humans, in humans also we contain almost 70 to 75% of water. So which is help us to maintain the body temperature is constant in a constant temperature. So but by means this, if you want to decrease your temperature, you have to lose a lot of energy. And also if you want to increase the temperature of your whole body, you have to absorb a lot of energy. So because the God has given 70 to 75% of water, in the whole body content. So that is how we maintaining our body temperature in a unit temperature. So for example, almost I think 37 degrees Celsius. Okay, the main property of water is containing higher specific heat capacity, which help us you to maintain the body temperature. When the specific heat capacity of water is very low, suddenly you could change your body temperature. For example, what do you mean? What do you mean by the specific heat capacity? What do you mean by this? Which means the amount of heat that should be absorbed or lost by this object to decrease the temperature by 1 degree Celsius of 1 kilogram of material. So that is the property of a material. You have to know the property of each material. So therefore the water is a material and water has 4200 specific heat capacity. So which means the water needs to lose 4200 joule of energy to decrease its temperature by 1 degree Celsius of 1 kilogram water. So you may think like this. If you want to make uh, a liquid reservoir and you have to maintain the temperature is constant, what are your expectation? The expectation of you is to maintain the temperature constant. When you lose a lot of a tiny amount of energy, if the heat capacity of the total system is low, suddenly it drops its temperature. But we need a constant temperature. So therefore, when the system absorbs a tiny amount of energy or lose a tiny amount of energy, the total temperature should be constant. So therefore, the system heat capacity should be high. For creating high heat capacity system, you need high heat capacity of liquid, which means you need high specific heat capacity liquid, which is suitable to maintain a constant temperature. That is how the human body is made up using by 70 to 75% of water. So this statement C, they are telling liquid P is more suitable than Q to make a liquid reservoir of constant temperature in the laboratory. So that statement is completely wrong because liquid P is not most suitable than Q. Liquid Q is most suitable than P because it has higher specific heat capacity when comparing with P. So that statement is wrong. Only the A is correct answer. The figure shows that a strong wind is blowing above a roof of a house which is having a horizontal ceiling. Following are the suggestions given by students to protect the roof removing by the wind. Keeping the doors and windows are open during the wind is blowing. Okay. Keeping the doors and windows are closed during the wind is blowing. Reducing the inclination of the roof to the horizontal. Increasing the inclination of the roof to the horizontal. Okay. The question is, there is a house which is shown in this figure, and there are some students suggesting some ideas to maintain the roof on the same position because there's a high wind is blowing. Okay, so this question is completely depends on the Bernoulli's equation. So usually, and you have to be noted the point that this house has a, yeah, this house has a horizontal ceiling. So usually, the horizontal ceiling means uh, which is separate the roof, bottom of the roof from your moving environment. So which means if you enter into the house, if you enter into this house, you cannot see the bottom of the roof. You can only see the ceilings. The ceilings mean the ceilings separate the roof bottom from your window air. So normally, if the air is blowing through the window, the air cannot enter into the bottom of the roof. So usually, this would be concluded from the horizontal ceiling data. Okay, now already you know that when there's a house which having a usual roof and it has no ceiling, so usually when you blow an air in this kind of room, this kind of house, when you blow, according to the Bernoulli's theorem, the streamline density will be increased in the top of the ceiling. So therefore, is any point in a fluid, any point, the velocity increases. Definitely, the pressure should be the velocity increases. Definitely, at that point, the pressure should be reduced. So therefore, usually, in any roof, when the wind is blowing so fast, so usually the roof is experienced on bottom low pressure area because of the higher velocity of air. The reason is the streamline intensity is high. Meanwhile, the bottom of air, when you close all the rooms, the windows and doors, the bottom of the air will be rest. So therefore, the bottom of the roof will experience the same atmospheric pressure. So now you know that when the velocity on the top part will be reduced, with increases, the pressure will be reduced. So therefore, if the roof will experience the net pressure difference upwards. You know the pressure means the amount of force which acting in a unit amount of area. So therefore, there's a difference in pressure which will create uplifting force which will lift up your roof. It is usually occur in normal houses, but you have to conclude. You have to be remember that this house has a horizontal ceiling, which means if you keep opening or closing the door, sometime if you keep opening, you can allow the air to passing through the whole house. But even it cannot enter into the bottom of your roof because it has been separated by the ceiling. So that is why for this question they are telling that keeping the doors and windows are open during the wind is blowing. That statement is right for the usual houses. Normally, when you enter into some area, you can observe this kind of house. But for this house, it cannot work out. For this house, it cannot work out. So the statement A is completely wrong for this house because it has a horizontal ceiling. If there is no horizontal ceiling, it works out and you can serve your roof. But for this house, you cannot serve it. So for the statement A is completely so it's wrong. So the B thing, keeping the doors and windows are closed during the wind is blowing. Keeping the doors and windows are closed. Yeah, that's also right. But this house, keep opening or keep closing, it never going to be work out for this house because the ceiling separates the air. You can the when you allow to enter the air into your house by opening your doors and windows, the air can move through your house, but it cannot enter into the bottom part of your roof. So you have to the question asked from to protect your roof. Okay, so if you have to protect your if you need to protect your roof, you have to reduce the difference in pressure. So for this house, whatever you do with by opening or closing the doors and windows, it cannot work for this house because it is a ceiling. So statement B also wrong. You cannot protect your roof. See, reducing the inclination of the roof to the horizontal. Yeah, that's true. Usually, the reason for the reduce in pressure because it's caused by the velocity of air. So when you reduce the inclination, the density of streamline on the top part of the roof will be reduced because normally when you are exposed to the lot of cross-sectional area, you have to cover lot of streamlines. But when you reduce the inclination, the cross-sectional area will be reduced. So therefore, the amount of volume which entered also reduced. So therefore, streamline intensity also reduced. When the streamline intensity reduced, the velocity also reduced. When the velocity also reduced, the amount of pressure which was initially decreased now is little bit it will increased. So therefore, the difference in pressure will be reduced. So what do you mean by pressure? Pressure means if there is a difference in pressure, which means there is a difference in force. So now the difference in pressure reduced, which will create a less force upwards. When the force is become reduced, then you can protect your roof because there is the no pressure difference when you inclination. What you say is reducing the inclination, which will create low speed air to pass through your top part of your roof. So it will work out. That will work out. For the C, the reducing in the inclination. Yeah, that's correct. D, increasing the inclination of the roof to the horizontal. Oh my God. When you increase it, the velocity, the streamline will be dense so higher before the inclination what you are created initially. So when you increase the inclination, the density of streamline will be increases, which means the velocity of air will be increased, which means the unit kinetic energy of unit volume also will be increased. So therefore, the pressure will be reduced further. When the pressure will reduce further, the point will experience a very low pressure. So when the bottom of your roof will experience a very low pressure, meanwhile your top part will experience a very low pressure. Meanwhile, your bottom part will experience the same atmospheric pressure. Meanwhile, your top part experience a very low pressure. There's a difference in pressure, so which will create a uplifting force, and your roof will be lift off. So they're telling that you have to protect it. So by increasing the inclination, you cannot protect. You can easily destroy your roofs. So that will not work out. So this question is answered on the C. That's it. Okay, for just move to the next question. Uh, but usually, okay, the answer is C. 8. Four possibilities of loading of an ice cube in the water beaker are shown in following figures. Figure A, ice cube is floating on the water with an air hole. So which means there's a hole. It is not a complete solidical ice cube. It has a hole inside. So which means there's no mass. Okay, you can conclude from the sentences. The ice cube is attached to the bottom the vessel using a string. Okay, in B figure B, you attach the ice cube using a string. Okay, ice cube is floating on the water with cork. Ice cube is floating with a metal coin. Okay, this completely depends on the Archimedes principle question. So basically, I'm just simply remind you Archimedes principle. If there's an object which is floats over the liquid, the amount of buoyant force which is equal to the weight of displaced water by this object, which means when the m is which means I'm telling you that when the object mass is m, when you put it into the liquid, it will displace this volume liquid. It will displace this amount of volume liquid will be displaced. So therefore, the displaced water has a mass. It has a weight. The weight of the displaced water, the displaced liquid, will be definitely equal to the weight of this object. This is what argument is said. Okay, for this question, you can conclude that A is also floating. B is not floating. B says a string, so it is attached. And C is also floating. D is also initially floating. So you know that when something is floating, definitely the mg forces should be supported by the buoyant force. Okay. So everything is buoyant except C. Everything is floating except B. Okay, now you can conclude that initially the A is floating because it has a certain mass. Usually that when there is the water, when you put an ice cube, usually it floats over the water because there's the density of ice cube is lower than the density of water because of the lattice. The lattice of the ice cube, you may study it in your chemistry. So the lattice create the ice cubes. The density will be is low when comparing with water. So you know that. But for this question A, they are asking that the situation which are not changed the water level when it is melted. Usually, that you can understand that usually when an ice cube melts into the water, the floating ice cube melts in the water level will not change because when ice cube starts to melt, whatever the ice cube, when it melts, it's changed into the water. So the mass of the ice cube cannot change. However, for initial mass is m of an ice cube. After it is changed to the water state, it's the mass will be never change. So therefore, the mass will be the same amount. So the mass is never going to be changed. So therefore, the displaced water level, the displaced water, the amount of volume also will never going to be changed because of it is floating. So after it is melted, so again the mass is same. So therefore, usually that when an ice cube melts in the water level never going to be changed. So therefore, you can conclude that for A, even there's a bubble hole, that is not a matter because initially there's a bubble hole. We don't need to displace the water for the bubble hole. We only need to displace the water for the available ice cubes only. So after it's melted, the water level will not change in the A point. But in B, after ice cube melts, you know that when ice cube transform into the water, the density will be increases. When the density increases, the volume will be reduced. So therefore, the ice cube will be shrinks. When it shrinks, the extra volume has to be filled by the available water. So then definitely the B part, the water level should be reduced. So B cannot be the answer. So the answer cancelled, fourth cancelled, fifth cancelled. Answer can be 1 or 3. So let's look at other things. Okay. in sea, but usually you know the ice, there's an ice cube and we are having a coke over the ice cube. So when the ice cube starts to melt, when the ice cube starts to melt, usually the melting ice cubes never change the water level, but after melting also it is a coke, so it is never going to be sink into the water. After melting also it has to be float over the water. So therefore when anything float over the water, definitely it should be displace the water, the amount of volume. When it is floats over the water again, definitely now also it needs to be display the water for initial mass, because the mass is never going to be changed, no? Therefore, the statement, so the figure C also, the displaced water level is never going to be changed. So therefore, the volume level, what are they asking? They're asking the water level is never going to be changed. So C is the correct answer. But even when you are observing the answer one and third, both answers are containing C. So you cannot judge only using C. You have to judge D is right or wrong. Okay, A is right, no? A is right. And C also right. So answer should be 1. But usually you may confuse with D. You don't need to confuse with D. Initially, the metal coin and the ice cube floating. So when it's float, usually you know that the metal has a higher density when comparing with water. So the higher density metal initially is floating, so it need to displace a lot of volume to maintain its body. So it is weight. So therefore, initially it has to be displaced a lot of amount of volume. The volume is supported by the ice cube. But after melting the ice cube, there is no volume to displace the water to support the mg. So therefore, after ice cube melts, there is no support for this metal coin. So definitely the metal coin going to be sink. When it sinks, it cannot initially it floats, which displaced a lot of water. So therefore the water level is raised up. But after ice cube melts, ice cube starts to melt. So definitely after melting, the ice cube has to fall down. The metal cube has to be fall down. So because there's no volume to displace, because the metal plate has only a tiny amount of volume. So definitely the D in the chapter we get D, the water level has to be reduced. So they're asking the not change. So the answer is only one. The one first answer is only correct. And B will be reduced. The A and C, the water level is never going to be changed. Meanwhile, B and D will be reduced. Okay. Question number 9.
Question number 9.
What is this? Okay. The three cells in a circuit are having zero internal resistance. Oh, excuse me. Okay, now I think just wait. Okay. The three cells in the circuit are having zero internal resistance. Usually every battery contains internal resistance, but only for this question types only having the zero internal resistance batteries. So it is so easy to conclude the circuit. Okay, three resistance of 30 ohms are connected to them. Another bulb of having 30 ohm resistance is connected externally as shown in the figure. The potential difference across the bulb is. Okay, when we are observing the circuit, they are asking that it is a bulb and they are asking the voltage difference across this bulb, and they are showing the earth symbol. So therefore you know that when any point you earth, the voltage at that point will be 0. So y point also voltage 0. So I'm just doing this. So okay, they're asking the voltage difference across the bulb. So you have to find out this is a voltage 0, and you have to find out the voltage at this point X. And the Y is okay, the Y is now currently Earth. So therefore this point also experience the 0 voltage. 0 voltage. Okay, now let's conclude. Okay, now when you're observing the voltage, you have to go through in the direction of the cells. So the cells are connected like this. So you know that when what do you mean by a cell means for 5 voltage means it means the voltage at this is a point A and this is a point B. The 5 voltage means with respect to the point A, the voltage at B is higher than 5 voltage. Higher in 5 voltage. That's what mean the electromotive force. Okay. Okay, by means this we know that 1.5 voltage increases, and also you can use the Kirchhoff law. By using the Kirchhoff's law, the 1.5 voltage increases. This direction also 1.5. In this direction is also 1.5, because every cells are connected in series. So therefore the EMF will be addition. So you have to add all the EMF of the cells. So finally you end up with 4.5 voltage increases in the whole whole closed loop. So you know that when you observe a whole closed loop, usually for this earth wire, there is no current. Okay, there is no current. Okay, so now for this question, you know that there are three identical resistors in three identical cells. So therefore, three identical resistors has to be experienced the same amount of voltage drop. So you can easily conclude that without any maths, you can conclude that every cells increases 1.5 voltages. So therefore, the three resistance are also identical. Therefore, each resistor will reduce the same amount of voltage difference, which means usually the current in this circuit look like this. So you can conclude very fastly without any maths. Okay. So by means this, every cells has a voltage difference which is equal to delta V is equal to 1.5 voltage. So therefore at this point is 0 voltage because it's earth. So this point will experience minus 1.5. When you are crossing this battery is in this according to this direction, in the Z point will be this point is 0. It is minus 1.50. Now it is increases 1.50. Again the potential at Z will become 0. And again the current is passing through in this direction. So this point will be minus 1.5. Again this point will be experienced the x, which means x will become to the voltage 0. So it is a simple question. 0. So they are asking the voltage difference across this bulb. Here also 0, here is also 0. So difference also 0. That's it. So the answer should be 0. That's a simple question. But if you don't understand this method, you can go with this method. But initially, you know, according to the Kirchhoff law, the total current is equal to the net total EMF over the total resistance. So you have to add up all the total resistance because it is series, and also you have to add up all the cells electromotive forces also because it's also in series in this circuit. So you will end up with I is equal to 4.5 voltage because the direction is same, no? So that is why I'm adding. And the total resistance should be 90. So you will end up with 0.05 amps. So now you know the current which into the whole circuit. So the current is 0.05 amps. So when you multiply the resistance with current, you have to know that you will get to know that the voltage difference across each resistance. So V is equal to IR. It is not V, it is delta V. The difference in voltage across the resistor. So the I is 0.05, 0.05, and the resistance is 30. So the voltage difference would become 1.5 voltage. Okay, that is the magnitude of voltage difference. You don't know the direction. You can conclude the direction by using the direction of current passing through. So the current is passing through this direction, which means the potential at Z will be higher than this point. The voltage at the point Z will be higher than this point because that is the reason why already always the current will passing from the higher potential to lower potential. So the current passing through this direction. So therefore the voltage at this point, I am naming this point as Q. So according to the passing this current direction of current, you can conclude that the voltage at Q is lower than Z. So definitely the answer should be 0. We have concluded in a simple way, but I'm just telling you that now the voltage difference across this resistor is 1.5 voltage. It is reducing, and also this cells is increasing. So there is no change in voltage when comparing with Z. So they're asking the voltage difference. The voltage difference is 0. So I hope you understand this. Next, let's move to the next question. Okay, question number 10. It seems like in a past paper questions. I think so. Okay. Two opened vessel of volume 0.2 meter cube and 0.3 meter cube are kept in the same environment. So you have to conclude that initially it is in the same environment. In every environment, this environment is same. The amount of absolute humidity also will be same because the environment, like it cannot be available a different kind of absolute humidity in each point. No, if there is an environment, The environment should be available in the same amount of absolute humidity. It never going to be changed for each point. So you have to conclude that. Usually you have to think in the way of questions. Okay. Room temperature is 30 degrees Celsius. Now, a packet of silica gel is inserted in the vessel of volume 0.3 meter cube and seal it. Okay. The other vessel is sealed with the inserting silica gel. While decreasing the temperature of both vessels, it is found that the new dew point of 0.2 meter cube vessel and 0.3 meter cube vessel are 15 degrees Celsius and 5 degrees Celsius respectively. The saturated vapor densities at 5 degrees Celsius and 15 degrees Celsius are 6.8 gram meter minus 3 and 12.7 gram meter cube respectively, the amount of mass of water vapor which is absorbed by the silica gel. So he states that there is a two container. There is a two container. I'm just downloads it. Okay, we can mark it here. So there is a two container. The volume of the container, I'm naming this for this A and B for better understanding. Okay, the volume of the A is 0.2 meter cube, 0.2 meter, and the volume of B is 0.3 meter cube. Okay, that seems pretty simple because initially the physics behind this question is, and you have to know that initially the 0.2 meter cube, this container's volume, and this container's volume is 0.3 meter cube, are kept in the same environment, which means you are capturing the same humidity air, which means initially you captured the same absolute humidity air. So initially the absolute humidity of the both container will be same because you are taking the air from the same environment. But after they are doing at 30 degrees Celsius, and now a packet of silica gel inserted into vessel 0.3. Okay, now you are adding silica gel into the vessel B, in the vessel 0.3 meters squared. I was naming it by B. Okay, usually you have to know that there has a point that you have to know by studying in chemistry, you have to know that the tendency of silica gel is absorbing the water vapor from air. So now when you are putting the silica gel into the container B, it is absorb the water vapor from the atmosphere, which is exposed to the silica gel. So now initially you know the absolute humidity in both room in the same environment. So in the same environment, definitely initially the absolute humidity will be same for the two container. But after you are adding silica gel, the silica gel has tendency to absorb the water vapor. So after the B will experience the low absolute humidity for this environment inside of the B. And now the inside of the B will experience low humidity, the low absolute humidity, and also the A is experience the initial absolute humidity. But you know the dew point of an environment, it's completely depend on the initial absolute humidity of the environment. When the absolute humidity is high, the dew point temperature will be also high. When the absolute humidity is low, the dew point temperature also will be go down. So you know that is what they are telling also. Okay, the 0.2 meter cube vessel and 0.3 meter cube vessel are 15 degrees Celsius and 5 degrees Celsius. You can see that the dew point of the A is 15 degrees Celsius. Meanwhile, the B container dew point is 5 degrees Celsius. The reason is the main reason why the dew point of the B is lower than the A, because it has low absolute humidity. But initially we take in the same environment though. Why there is a difference in the dew point? Because the silica gel absorbs the humidity of air, so that is reduce the absolute humidity of this environment, which will reduce the absolute humidity. So when the absolute humidity is reduced, the dew point also reduced. But in any environment, the initial absolute humidity will be equal. It'll be equal at the dew point saturated vapor density. I repeat. Okay, initial absolute humidity will be equal to the saturated vapor density at dew point. So that is why it's saturated, and the further amount of water vapor will be condensing. Okay, you know that. That is the point you have to remember at this point. the absolute humidity will be equal to the dew point saturated vapor density. So you can conclude that. So in this same environment, the same environment A, there's no silica gel. So the environment A experiencing the 15 degrees Celsius as a dew point. So in 15 degrees Celsius, you know the maximum saturated vapor density is 12.7 gram. So by only looking up A, by only looking at A, you can conclude that initial vapor density is equal to the dew point vapor density. The maximum saturated vapor density at dew point will be equal to the initial absolute humidity. So therefore, you can conclude that the environment initially has absolute humidity, which is equal to 12.7 gram meter minus 3. Usually, you know that absolute humidity means the amount of water vapor which is available in unit volume, unit 1 meter cube. So usually, initially you take the water vapor in 0.2 meter cube. You didn't take the 1 meter cube or 2 meter cube. You take it only 0.2 meter cube. So we have the unit is only available, the amount of water vapor which is available in 1 meter cube. So you have to find out how many water vapor initially you have taken. So you have to multiply 0.2 into 12.7. So you will end up with, so you don't need to multiply here. You don't need to multiply here because you have to multiply on this point. Because whatever the absolute humidity, whatever the, even if you take not 0.2 meter cube, even if you take a 5 meter cubes also, the absolute humidity will be same. The box A is only giving to the reference to go to get to know the absolute humidity initial environment. There is a good question. You have to use your deeper ideas in the humidity section. So I'm just telling you the explanation. That's it. Okay, now we are going to move on. So now you can conclude that, okay, initial absolute humidity of the environment is 12.7 gram per cubic meter, but you only capture the water, the volume of the air is 0.3 meter cube. So when you multiply this 0.3 into 12.7, so which will give the initial water vapor which you captured in the 0.3 meter cube. But they are asking that initially you captured amount of water vapor, but the silica gel absorbs some amount of the water vapor from the environment. So further, the amount of absolute humidity will be reduced. But after reduced absolute humidity, you know that you can obtain from the dew point. So the dew point of the 5 degrees Celsius is equal to 6.8. So you can conclude from this data. So initially you capture the water vapor, amount of water vapor will be equal to 0.3 into 12.7, which will 3 into 3.81 grams. 3.81 grams of water vapor. Initially you captured in 0.3 meter cube of air. But after you are putting silica gel, the silica gel is absorb some water vapor, but you don't know how much it is absorbed. But you can find out by using the dew point after putting silica gel. Sometimes you may think that if silica gel absorbs all the water vapor, what will happen? How do I decide? No, there's data. If silica gel absorbed all the water vapor by level in this environment, there is you cannot observe the dew point, but you are observing dew point at 5 degrees Celsius, which means it didn't absorb all the water vapor. So therefore, it only absorbed a tiny amount of water vapor. But you can find out after absorbing the water vapor, there's a leftover is also there. So the leftover, you can conclude the leftover water vapor by using the currently available absolute humidity. So after putting silica gel, the absolute humidity will become 6.8 gram. You may think that the 5 degrees Celsius is only the saturated vapor density. I'm again repeat, at dew point, in the point of dew point, the saturated vapor density will be equal to the initial absolute humidity. Okay. So after putting silica gel, you know that the dew point 6.8. So by using this 6.8, after putting silica gel, the absolute humidity of the container B will 6.8 gram meter minus 3. Okay, that means the amount of water vapor which is available in a meter cube, but you didn't take a meter cube, you take only 0.3 meter cube. So you have to multiply 6.8 into 0.3, which will give you the amount of water after silica gel absorbs the water vapor. So you have to 3 into 6.8, which will end up 2.04 grams. So finally you finished. I mean, you know the initial water vapor in the container B, which is 3.81 gram by using the data. And again, after putting silica gel, now the currently available water vapor you have been count out. So after putting silica gel, the amount of available water vapor 2.0804 grams. So they are asking the amount of water vapor which is absorbed by the silica gel. That's simple. No, you know the initial water vapor and now you know the final available water vapor. So the difference, which is the reason for, which is the difference amount, the difference in the water vapor, the difference will be absorbed by the silica gel. So you need to find out the difference. You have to substitute 2.04 from 3.81. So you will end up with 3.81 minus 2.04. You will end up with 1.77 gram. So the answer is fourth answer. That